Hello everyone and welcome back to the tutorial again. In this section, we are going to discuss as about what are the different forms of multi-GPU communication mechanisms that are modeled in MGPU SIM. So the first is a GPU to GPU RDMA, where RDMA stands for Remote Direct Memory Access. So in this form of communication, when one GPU wants to access data on another GPU, it basically forwards its request through the RDMA and then which can then fetch the data from another GPU's local memory. So the way this works, or the protocol through which it works, is modeled as follows. Whenever an L1 cache has a miss, it will check the physical address of that request which caused the miss. Then if it knows, or if it finds out that the data is located in its own local partition, then it will forward it to the L2 cache. However, if it finds that the data is on another GPU, which can basically be easily found by looking at the physical address, then the request will be forwarded through the RDMA engine to another GPU. The way by which the L1 cache can know whether this particular physical address is on this GPU or another GPU is basically just maintaining a simple map of these physical memory partitions. So currently there's one RDMA model per GPU and which works as a message switch. So whenever the L1 cache has a miss, it will first forward its request to the RDMA in case it finds out that the request or the data is present in some another GPU. The RDMA on that particular GPU will first handle that request, and then it will forward the data to the RDMA on the other GPU. This RDMA will then receive that request and forward it to the L2 cache, since the L2 cache is supposed to have the most recent copy of the data. So once the L2 cache receives the request, it will either service it in case of a hit, or in case of a miss, will send it down to the DRAM of this particular GPU. Once the data is fetched back, the RDMA will then respond back to the original RDMA that made that request, which will then forward the request to the L1 cache. And then the L1 cache will forward the data to the compute unit. So this form of communication is one of the most common bottlenecks in NUMA systems, because the penalty of accessing remote memory through RDMA is extremely expensive, as it has to go through this entire long latency link. So this is an important modeling that is required to study multi-GPU systems. Another form of commonly used multi-GPU communication mechanism is GPU to GPU page migration. So in MGPU SIM, we model a first touch based demand paging. So in page migration, the basic mechanism is that whenever a GPU has a page fault for a page that is not present in its own memory, the IMMU and the GPU driver will migrate the page from either the CPU or from another GPU to that GPU. So this is also a long latency process and involves multiple steps. This includes things such as the TLB shootdown, the flushing of the memory pipeline, the flushing of caches, since it L2 cache, since it contains the most recent data. And then for the page migration scheme, it is important to have some sort of centralized mechanism which keeps track of which page is on which GPU. So this is again maintained by the IMMU. And finally, there's a page migration controller, which is responsible for orchestrating this movement of page from one GPU to another, or can be from one CPU to a GPU as well. In the next section, we are going to take a look at what are the different multi-GPU variations that are currently supported in MGPU SIM. So this will explain the different models of multi-GPU that are currently available, as well as what are the memory models that are supported for that form of multi-GPU.